Probability is the chance that something will happen. All probability has a 0 to 100%. Even if you drop a pen, according to probability experts, the pen never has a 0% chance of landing on the ground. All of the probability answers that you will have will either be more than 0 or less than 100%. Therefore, if you get less than 0, a negative probability, or you get more than 100%, then you're probably doing something wrong. Let's look at a few examples. First, I think the most simple example that we can look at, it would be the example of what is the probability that a point will be in the sector of the circle. And what I mean by the sector of the circle is this part of the circle, the small little piece of pie that has an angle measure of 30 degrees. Now, last unit we looked at finding the areas of the sector, and part of that process was to take the measure of the angle and then divide by all of the angles within a circle. And then we reduce that to a fraction. And then in order to find the probability, we also need to write the fraction as a decimal. And then finally, we can express it as a percent. So in order to find the percent of a probability from a fraction is to take the decimal part and multiply by 100. Let's look at another example. Let's say that we have a circle that has a radius of 3. We have a rectangle that has a width of 3 and a length of 5. And both the circle and the rectangle are in a larger rectangle that has a length of 15 and a width of 10. Let's figure out the probability that a point chosen at random will be in the circle. This is the same idea as comparing the area of the circle with the area of the rectangle. So first, find the area of the circle, 3 squared pi. That is approximately 28 and 27/100. And then we need to find the area of the blue rectangle. That is 15 times 10, so that's 150. And then we got to take the area of the circle and divide it by the area of the rectangle. So here we have a fraction that's comparing the areas of the circle and the area of the rectangle, and that will be a decimal that is 19/100, and the percent is 19. Let's be exact here. and 85 hundredths. Now, let's look at the other one. What is the probability that a point chosen at random will be in the black rectangle? Well, of course, we have to find the area of the small black rectangle. Let's call that BA. And that is 3 times 5, which is 15. And so we're going to take 15 and we're going to divide by 150. That will give us 1/10, which means that it is a 10% chance that a point chosen at random will be in the black rectangle. What's the probability that a point chosen will be at random will be in the blue rectangle but not in the circle or the black rectangle? There's a couple ways to look at this. Either you can take the percentages and add them together and take them away from 100, or you can take the areas 28 and 27 hundredths and add them, and then take them away from the area of the total, and then find out the decimal that the area of the circle and the black triangle together is compared to the blue rectangle. And that is 71 hundredths, and the percentage is 71 and 15 hundredths. Another example related to the sector is what is the probability the spinner will stop in each sector. Now, what we can see here is that this spinner is cut up into eighths. And the blue is 2/8 or 1/4. The red is 1/8. The green is 3/8. And the yellow is also 1/4, like the blue. Now, in decimals, 1/4 is 25 hundredths, and a percentage is 25%. 1/8 is 125 thousandths, or 12.5, or 12 500ths percent. Green is 375 thousandths, or 37.5%. And then yellow is the same as the blue, 25 hundredths, or 25%. So here, using the idea of this spinner is cut into eighths. Now, alternatively, in some examples, you're given that each sector is also an angle. And so, let me just fill in what an alternative you might see. you might see instead of the circle cut into eighths, you would see it cut up into degrees, and you would actually have to take the degree. Let's take, for example, the blue, the degree of 90 degrees, and divide it by 360. That will still give you 1/4 and 0.25 and 25 hundredths. Here's another scenario. There's a stoplight at an intersection that has a 60-second cycle. The green light lasts 25 seconds, the yellow light lasts 5 seconds, and the red light lasts 30 seconds. Now you can actually represent this as a line segment, or I should say one line segment that's made up of individual line segments, where you have a line segment of 25 seconds, and you can think of 25 seconds as the length of the segment. Okay? We're just using a segment lengths to represent length of time. So the entire interval of time would be 60 seconds. Let's look at a couple scenarios. What's the probability that you will arrive at the intersection and have to stop? Well, that's represented by the 30-second or red light. And so you have a chance of 30 seconds out of 60 seconds, which is 1/2, 0.5, or 50%. Let's look at another scenario. What's the probability that you will arrive at an intersection and have to wait more than 10 seconds? Well, that is represented by the 20-second interval within the 30 seconds, because this is when you would have to wait more than 10 seconds. If after this 10-second mark right here, then you're good to go. You can wait for 10 seconds and go on your way. Everything else is less than 10 seconds from here to the end. And so this is represented by 20 seconds divided by 60 seconds, which will give you 1/3. That will be 0.3 repeating, and 33 and 33 hundredths repeating. Now notice that I wrote both the decimal and the percent with the repeating. Make sure you do that in your answer. We want to be exact. Oh, I guess I'm going to have to leave that there. Okay, now, what if you drive up to the intersection 10 times, how many times will you have to wait more than 10 seconds? Well, if you remember from our last question, we had that you had to wait more than 10 seconds 1/3 of the total number of times. That means that if you drive up 10 times, then 1/3 of those 10 times you're going to have to wait. And that is 3 and 33 times repeating, which means that out of all of that, that is 3 times.